Hello and welcome, folks. We're back. It's the most wonderful time of the year, and we are back with Advent of Code 2023 Day 1. I'm super excited to be here. Not gonna lie, I almost look forward to this all year round, and when it's finished, I get very sad. So I'm delighted to be back. We're going to be doing the same thing we did last year. I'm going to be attempting to do each puzzle on the day it's released and release an explainer video on the same day. And we're going to see how far we can get into this. Last year, I didn't quite make it. I think I got to day 21, 2, something like that. Anyway, there's a playlist you can find on my channel for last year's, all the solutions I got up to, all the videos I made. So we're going to do the same thing this year. So yeah, let's just jump in with day 1. So before we start, I should say that this day 1 I actually thought was pretty difficult. Considering it was just a day 1 puzzle, usually the pattern with this is day 1 is usually very easy, and then, day 2 gets a little harder, and, it stacks up till eventually the problems get to be quite difficult. But for a day 1 puzzle, this was kind of non-trivial a little bit, towards the end, the second part at least. So there's a few little gotchas. We'll go through it anyway. It wasn't a crazy complicated problem, but there was just a few little bits where it was a little bit more difficult than I had seen in previous day 1s. So let's jump into the problem, and then we'll have a look at the code. So day 1, trebuchet? Question mark, exclamation mark. So we start off with a little skit. This year we're looking at the overarching theme seems to be we're looking at snow production, issues with producing snow, and then they basically want to launch me in a trebuchet. And that's it, because snow comes from the sky. It's perfectly reasonable rationale. So they go through the whole thing. Yeah, there's basically, they need to calibrate the trebuchet to launch me, obviously, to the exact correct place or whatever. And they have this list of these values that are the calibration values they need, and someone's messed with them. So basically our job is to unscramble those calibration values and get all the numbers out. So the example they have here, this is what we have. So it says that each line in your input should be basically a 2-digit number, but the scrambles are like these letters that are in between. So what they say is there should be 1 digit, and then there should be like a final digit, and they'll make a 2-digit number, and you add all those together, and that gives you your answer. So you see here we've got 1, ABC, 2. So what they want is they want you to pull out 1 and 2, make the number 12, and then figure out what each one is and add them all together. So you go down again, you've got a 3 and an 8, makes 38. And then this one has more numbers in it. So if you go through, you got like a 1, a 2, a 3, a 4, and a 5. So what they want is just the first and the last. So then we got a 1 and a 5, which is 15. You get the picture. And then actually the last one here, the last little gotcha, if there's just a single digit, then it's both the first and the last. So that 7 in trebuchet there becomes 77. So yeah, this isn't terribly complicated. Basically, my first instinct was to go through this and create, just go through each character and basically just throw out a character if it doesn't match what I expect, and then keep the character if it does. At the very end, filter it down, pick the first and the last, add them all together, then that's it. So let's have a look at the code. Here we are. It is, how many lines of actual code? Like 8 lines of actual code. So first thing we do, we're creating an array for all the numbers to fit into. So this is basically, that'll be the values of each line. The value for each line that you come up with. So then we can just sum them all at the end. We go through the file line by line, and then for each line, what I'm doing is creating an array that will hold the numbers that are in each line. So what I want to do is if I come across that number 1, I want to put it in the array. If I come across the number 2, I put it in the array, so on and so forth. And then once I've gone through the entire thing, I'll take the first one and I'll take the last one and combine them together to make my value for that line. So we go through each character. Now, this is a bit of a weird way of checking it, but basically what I do is I take the character in Ruby, I cast it to an integer. And in Ruby, if you take a character, a string character, you cast it to an integer. If it is itself an integer value that comes out, so if it's the number 1, it'll remain as the number 1 when you cast it back to a string again. If it's like a letter, like A, B, C or whatever, when you cast it, it'll go back to 0. So then effectively, if you do this casting to an integer, then back to a string, if it equals itself, then I know it's a number. It's janky, but it works. And it's, it's not it's kind of silly, but it does work. Definitely is a better way to do that comparison. You can do this with lookups and stuff as well, which would be probably a bit smarter, but anyway, this works. So I end up with each of my numbers then in a list, and then all I have to do is pull the first one, pull the last one, combine them together. So because these are strings, then this will just be a concatenation, and then I cast it to an integer again, and that gives me a number, and then I can add it to the array, keep looping, do the whole thing, add them all together, and that is it. So this does work. Let's go run one sample, and there we go. It's 142, which is what the sample answer should be. So yeah, this works. All right, let's go on to part 2. So yeah, nothing crazy complicated here, and part 2 is equally not crazy complicated, but it's a little bit different and requires a little bit more thought. So my solution for part 2 does actually work exactly for part 1 as well, but it's a very different type of solution. So I would say this is kind of what I would call a very naive solution. It's just loop through, check values, it works fine. Typically on day 1 and 2 and 3 and 4, that kind of early stages, this very naive solution could also work quite well for the second part. This isn't the case where that happens to be the case. I did need to do a more advanced solution for part 2. So let's have a look at how they've changed up part 2. So part 2, we go down, and yeah, so it says now they're basically changing what our input is, or they're changing how we want to parse the input. And it says that some of the numbers have now been spelled out in words. So we've got 1, 2, 3, 4, 5, 6, 7, 8, and 9. And these are counted as valid digits now as well. So in this sample example down here, you can see we've got 2, then we've got the character 1, and then we've got the word 9. So out of that, we need 29 is what we need to extract. So already you're seeing that this is a little bit different. So now they've changed what was just a very simple exercise in picking out single digits, and now we're having to match whole words, but also we still need to maintain that we're matching single digits as well. So you see down here in this line, we have a 4 and we also have a 2 at the end. So we can't just go, match 9 and 8 and 7. We now also need to combine them together. Same here, we need to match a 1, which will be the first one, and then we also need to match a 4, which will be the last digit for this one. So it's a little bit trickier. And I didn't instantly have a very good way of doing this. The way I did it, I basically ended up using regular expressions, regex, and I hate regex. So it's not something I arrive at, first of all, when I try and do a solution. Generally, if ever I've had to do something with regex, I've gone to myself, that was really handy. I should remember how to do that because that was really useful. And then I never do. So every time I have to come back to it, I'm like, oh, geez, how does this thing work? And I always forget. But anyway, regex did save me in this one. So I will show you the code. And then I'll show you there's one gotcha that got me with regex. And this is another example of where I was using this thing that I never really use, and I completely forgot that this was even a thing that I'd have to consider, but I did. I'll show you anyway. So going back to the code, we look at part 2. So what I did up here, first of all, I made this like map thing, which just lets me extract a common value out for each of these. So if I have a string of 1, I know the value is 1. If I have a character 1, I know the value is also 1. So it's just a convenience thing to let me map stuff together. You'll see where I use it later on. Totally unnecessary, but it's just a way that occurred to me to do it. So effectively, what we do is we're doing a very similar thing, except what I wanted to do this time was, because I knew I needed to match on different things, I needed a way of being able to just go through the entire string and basically return the instances of all of these different things that might appear in it. And then with that in a list, I could take the first one and take the last one and do the same thing as I did before. So the way I did that was I used this scan method in Ruby. So this is part of the string library, and basically what it lets you do is it lets you insert a regex pattern, and then it will return all the instances in an array of where that regex matched. And so what the regex that I did is pretty much the most basic thing you can do. I'll actually just type it here so it's obvious what it is, but it was something like this. So I think you do like // and then it was like 1 and then pipe 2, pipe 3, so on and so forth, and then it's like pipe 1, pipe 2. And what this does with the pipes is it basically is an OR operation. So it'll pass through the entire string and it'll check, do any of those things match anywhere in it, and it'll return each instance where you find something that matches there. And that is it. It's as simple as it gets. It's not an efficient regex at all, but it works, and that's all I cared about in this instance. Just a little tool that'll do the job. So that's down here. Basically, we pull that in, we scan through, we get our list of words. Then at the end here, all I do is I take those, the first, and I take the last. I look them up in the map here just to extract out the numerical values, and then I do the same thing, combine them together into an integer, put it into the list, and then at the end I can just sum it all together. You can ignore this line. That was just for me to do some debugging, because there was a little edge case that I didn't get, and I had to go and do some debugging to figure that one out. So anyway, this works. So we can go sample 2, a different sample, put it in, and we should get 281. Yeah, and then this also works for the original sample as well. It gives you the same answer. Yeah, 142. What you will notice though is with this regex, I said it wasn't an efficient regex pattern, and I think regex is known for not being terribly efficient. Or maybe it is efficient. I don't know. I might be completely wrong on that. But in my head, always, whenever I've done regex, maybe just I don't know how to use regex, it's always been a little bit inefficient. But you notice for part 1, so this code using the regex solving the sample for part 1, it takes 0.001 seconds. Whereas for the original code that I wrote, it's 5.3 times 10 to the minus 5, which is 0.000053. So it's a lot slower, but it's still pretty fast, so I don't mind. Anyway, the only thing that caught me out with this then is one thing that's in the it's in the example text. Actually, they show it to you in the example, so it's kind of a hint. I'm guessing that they suspected that if people used regex to do this, they might end up running into this problem. So that is down here. It's actually in 2 places in the example, but they're both 2 places in the example where it won't actually fail the sample. But if you notice the pattern, you can see how it might fail. So that's down here. You've got this, say, 9 and 8, and you've also got this one 1 and 8 down here. So it's this is where you can see the example. So 9 is NINE and has its own E, and then 8 is EIGHT and it has its own E, and they're beside each other, but there are separate words. Where they show you the thing here to point it out is you've got 1 and 8 down here, and they share the E. So the last E of 1 is the first E of 8. So if you do a regular regex match on this, I think, now I'm not 100% certain if this is correct, but my understanding is that as regex goes through, it basically will discard things that it's already matched. So it'll break the string down. It'll say, well, I've already matched up to that point, so it'll discard that, and then it'll only look forward. So now it's discarded this, and now it's just looking forward at IGHT, which obviously isn't the word 8, so it won't match it. So there is definitely cases in the full input file where that actually makes a difference, because I didn't have this at first and I submitted my answer and it was wrong. So this is where I was caught out. There is a simple fix for this in regex itself, which is a thing that's built in, and it is called a positive lookback. So if you see, this is our little regex example here. Now the syntax is a little strange, but basically what it'll do is it'll look back at things that have already been discarded as such, and it'll try and attempt to do the matches there too. And the syntax is like this, exclamation mark equals this, And that's it. I think, well, hold on, let me just do that right. I think this is the correct syntax anyway. So yeah, it's like that. So I have that put down in here. So it's the exact same regex pattern that I do here. Actually, I never mentioned that. That's another thing I use this map for, is I can just join them together with a pipe in between them in a string operation, so I didn't have to type out the whole pattern. I just had to have it in this list. So yeah, then I was able to just wrap this little, what's it called, this little look back around it, and that worked then. So that's the pattern that worked for me and solves the problem. So that is it. Yeah, like I said, it's a little bit tricky for a day one problem. Trickier than I thought it was going to be, but that gives you a little bit of enjoyment, I think, from day one. Like there is a little bit of a sense of achievement, because sometimes from the very start you can be a bit like, okay, well, that was done, that's fine. But then this had a little bit of something extra, so there was kind of an extra sense of achievement for getting that done for day one, which is a cool way to start. So yeah, that's it for day one. I hope you guys enjoyed. And yeah, we're going to come back tomorrow for day two. If you want to have a look at my code, there's a link in the description to my GitHub, where you can find all the code that I'm publishing for each day. And yeah, we'll leave it there for now, and I will see you guys tomorrow for day two.